Good afternoon, everyone. Good afternoon. Hope all is well.
Afternoon.
Hey, hope everybody's doing all right. Just checking one thing before we get rolling.
Enjoy your vacation.
It was good. It was good. I didn't have Wi-Fi at all, so that kind of messed me up. I had plans to do some things, but
Oh, you know you like that.
No,
so
wifey set it up like that. He ain't gonna be working on this vacation.
What I'm talking about.
He
You're
already
probably
had
right.
looked that up.
You're probably right. Sabotage. I was sabotaged from the beginning. So we wanted to go down there. Okay. So last class, y'all remember, well, not last class, last week, we prepped for the test, and then we actually took our test for chapter 7. Nope. Why do I have an 8 and a 1 down here? Let me check. So I'm gonna see 9.
It's
7.
chapter 4, wasn't it?
I'm trying to check, make sure that I'm in the right spot. It might be 7. Yeah, hold on. We didn't do lines and angles at all in this class.
No, we did
Oh.
chapter 4, the last
4.
chapter.
Oh, okay. Okay. I thought we was ready to jump into chapter 9, be done with the class, but y'all wanted a whole other chapter. It's all good though. All right. So let's look at chapter. We're looking at chapter 7 today. And let's see, we got looking at 7-1, 7-2. I know we're going to do 7-3, 7-4, 7-5 together. So we're looking at 7-1 and 7-2 today. I got to go to my other. So just copy down the titles of 7-1 and 7-2, and I'm going to go to my other page of notes.
You're gonna do both 7, 1, and 2 today?
Yeah, we should be able to. I'm going to check to make sure. I got to see how long 7-1 is. 7-1 lines and angles. I know 7-2 is a short section because we do those together. Let's see why I didn't put notes on this anyway. Let's go here. Measurements. Let me check one thing, don't copy it, then make sure something real quick. All right, so here we go. Starting right here, lines and angles. And this is what 7.1 for us. I need to go ahead and this is what I'm going to do. Didn't need to do that. All right, so let me put some stuff. All right, so 7.1 lines and angles. So looking at this first one, just making sure we're okay with line segments and how they operate. We have X, Y, and Z are all a line L. It says given the XY is equal to 9 meters, YZ is twice XY. Find XZ. All right, so right here is just a diagram of what they're talking about. So we see that this is XZ. And if you want to create an equation, XY plus YZ is equal to XZ. And they tell us XY is 9. And then YZ is twice XY.
18, so it's 27.
Mm-hmm.
I haven't finished copying that yet.
Too late. Too late.
So 9M is the
9 meters.
slope.
Mhm.
Is that considered this?
You said it's considered what now?
That's 9M,
Mhm.
and the M stands for slope.
Meters. No, we're totally different thing now. So we're talking
Oh,
about measurement now.
meters now. Oh, you gotta let me know now. That stands for 9 meters. Okay.
Mhm.
Wait a minute. Wait a minute. So that's 9M, which is meters.
Now, if it said M equals, then you would have had a point there. But no, if it follows behind your number, then it's measurement.
XY is twice. So when it says find XZ, okay. So is this what we do on the not slopes, but what you call it?
Mhm.
Graph. Is this like the grafting line as well?
We
or
totally different chapter. Different
no
chapter.
grafting at all? Okay.
Mhm. We in totally different chapters. Yeah, don't try to connect them. They ain't making you connect.
Okay. All right.
Are you done with the red?
So I see you got a little 9 above the X and the Y in between the two dots. What does that signify?
Mhm.
Did you hear me, Professor? No,
Yeah.
above
No,
the
no,
X.
that's what you asked what it signifies. I'm saying it signifies this. XY.
XY is equal to 9 meters. Okay.
Mm-hmm.
So that 9 is there. Okay. All right. Okay. So if we were to do this in the book, you expect us to put that 9 there, or you just showing us that?
Well, it's up to you how you want to process the information. I'll put the 9 right there because that's what it represents. They gave us that XY. This segment right here is equal to 9. So I just put it up there. Yeah, so it's up to you how you use the diagram and all the stuff like that.
So it would have been saying the 9 is the XY, and then it say 2 9. So that would have been the X and Z. So that's how we would come up with the 27.
Well, two times 9 would have been
Right.
YZ. YZ. Because it says YZ is twice
YZ.
Y.
Okay.
Mhm.
Wait a minute. Oh. So could do this if I didn't have so many formulas to remember.
Mhm. Mhm. All right, questions on it? Questions on what we did? Make sure we're okay. All right, questions on the relationship, what we did here. Make sure we're good. All right, can I scroll up?
Okay.
Everybody good? I can scroll up. Don't copy this next example. I'm about to scroll past that. Everybody done with the blue?
Yes.
All right. Let's go to parallel lines. So parallel lines are lines that never cross or touch. They're gonna have the same incline. We talked about that. I believe we talked about that in this class when you have the same slope. Lines have the same slope. But if not, they have the same incline, so they have the same slope. Then perpendicular lines are lines that create a 90-degree angle at the intersection. And so you can never assume that you have 90 degrees. You do have to have some type of indication that it's 90 degrees. So it may be this square or maybe in the directions, but you can never assume that you have 90 degrees, 90 degrees. All right, can I scroll up?
Okay.
All right, so then we get into angles. Angles are two rays. They have the same endpoint. And that endpoint is called the vertex. Let's scroll up, scroll up. Everybody done with perpendicular lines?
Why is it called a vertex?
Hmm.
So why is it called it? Because,
Now why? I don't know, but
okay,
what is this point right here where the lines intersect? You know where they meet at?
I think that's what I'm asking.
Yeah,
Okay.
yeah. That point right there where they meet is it's called the vertex.
Okay. Okay.
Vertex of your angle. All right. So everybody done the vertex thing, scrolling up. Okay. Next, we're looking at types of angles. We have our acute angle. That's between 0 and 90 degrees. Right angle is exactly 90 degrees. And remember, you have to see that square, or like I said, it has to be in the directions. You can never assume that you have 90 degrees. Obtuse angles is between 90 and 180 degrees. So I'll give you a chance to copy that before I push up. Okay. You have straight angle, which is a straight line, same thing. Straight line or straight angle, same thing. That's 180 degrees. And then a full rotation or a full revolution is 360 degrees.
So Professor,
Mm-hmm.
with the obtuse angle with the little point at, that is the vertex of that as well.
Oh, yes. Uh-huh. Mm-hmm.
With the, the obtuse one,
Yes.
that
Mhm.
would be the vertex. Okay.
Yes. Uh-huh.
The point meets wherever the point. Okay. I got that.
All right, scrolling up some. Of course, if I go up too far, let me know.
One more question, Professor.
Yes, ma'am.
Now, where the point meets on the straight line, that ain't considered because that's not two separate lines. That wouldn't be considered a vertex, right?
No, that's your vertex. That's your
It's
vertex. It's the same thing. It's just that the line, you know, when you talk about where the graph started or the angle started, it started here and went this far, and that just created a straight line. So yeah, so it's still, in other words, it's still this same process. It's just that it opened all the way up to a straight line.
Oh, okay.
Yeah.
So wherever,
Oh, okay.
wherever
Okay.
that point is, that's where the vertex is. Okay.
Exactly. Mm-hmm.
Always where the point at.
Mm-hmm.
Okay.
Excuse me. All right, scrolling up some. So we got complementary angles. That's when two angles add up to give you 90 degrees.
Okay. Okay.
Mhm. So there's just examples. 50 and 40 are considered complementary. And then at 1 degree and 89 degrees are considered complementary angles to each other.
Okay.
Mhm. And we have supplementary angles. Those are two angles that add up to give you 180 degrees. All right, everybody okay before we go to the next example?
Yes, thank you for asking.
Mhm. No problem, no problem. So it says, given that, notice we have the symbolism here, M, then you have like an angle, then
Mhm.
ABC. So that represents the measure of ABC. We're gonna put ABC in there. Or I could write Oh, drop my pen. The measure of angle ABC. So that's what that represents for us. So the measure of angle ABC is 84 degrees. Find the measure of angle X. So they would have given us this diagram right here. And notice they say that ABC, this is ABC. So the whole thing is equal to 84 degrees. And they give us 47 degrees in there, and they want us to find angle X. So whether you set up this equation or not, all you have to do is subtract 47 from 84. You know, that's basically what you're doing. You know, I'll set up the equation just to make sure we're okay with how that would look. But basically, you know that the whole angle is 84 degrees. Part of it is 47 degrees. So subtract 47 from that in order to get X, the other part that's missing.
So that's how I got 37. Okay.
Mm-hmm.
Okay, get that.
Did you go over that again, Professor?
Well, the whole thing is 84 degrees, ABC. You see that, ABC.
Mhm.
And so if you want to know what this is, you subtract the 47 from that 84. Right? If you want to know what this part of it is,
Mhm.
but you have this part, you subtract that from 84, the total amount. And that's all this was over here.
Oh, wait a minute. Give me a chance. Can you give me a chance to write that problem now? I'm still stuck on the angles, trying to figure that out. Okay. So let me just give me a chance. And so we're always to write the angle sign in front of it to
Directions. That just came with the directions, you know. So you know, math lab would just be asking for the 37. So that's all you're doing is typing 37 in the answer box. But as far as the rest of the stuff, that would just come along with the instructions.
thank you, sir. I got it.
Mm-hmm.
Easy so far. Angle, let's ask for angle.
While he explained it to me, it was.
Hmm?
I say it's easy while you explaining it.
Oh. Everybody doing that last one, going up the vertical angles. All right, so vertical angles, next thing, formed by intersecting lines. So the non-adjacent angles are the vertical angles and are equal. So in other words, when you look at just two lines that intersect, you know, to make an X or whatever, the opposite angles are the vertical angles and they're equal to each other. So that would be 1 and 3, and then 2 and 4. So those are vertical angles.
Professor, you know what I'm having a problem with?
Mm-hmm.
When you pull it up, and while I'm trying to write down what you're doing, you're showing me at other things. So I'm missing that because I'm trying to write down, go ahead and start writing my stuff down. So I'm missing when you're explaining it at the example. So it makes me have to come back and say, wait a minute, now what did you say about that? Because I was so busy trying to write, because trying to stay caught up. So, hoping maybe you could let us write it and then explain it. Because like I said, while I'm writing it, then I'm not seeing what you're showing me on the axis.
Right.
You
So I'll try to create a better balance, but you got to remember I'm balancing, but 20-some students. So everybody processing information different. So, and I'm pretty sure everybody's writing different too. So I'll do more. Yeah, I'll try to do more with balancing that. But trying to consider everybody too. So I'm just talking. Really, I'm kind of filibustering and letting y'all write and
Mhm.
stuff like that. You know what I mean? I call myself trying to do that. So yeah. And you know, if you ask a question, I don't mind saying it again. It's not a big deal.
Okay.
Yeah. So you know, I thought I was doing all right saying it again if y'all need it. Because you know, I don't mind saying it again either, because sometimes you do repeat things anyway so that people get it the second time and stuff like that. So when I talked the first time, I don't mind saying it again if somebody want to hear it again. So it's not a big deal. All you gotta do is, you know, say, yeah, can you say it again? You know?
Okay. I feel like I'd be holding up class, asking, wait a minute, can you
Of
say
course
that?
you're holding up class. I'm trying to go. No,
But I be missing it, so I have to ask you to repeat it, 'cause
fine.
I'm trying to write this down. I probably don't write that to everybody else.
Miss Glover, he know he got me and you in here.
Yeah, you're fine. You're
Well, I
fine.
understand you got the other students too. So
Yeah,
I
yeah.
mean,
So yeah, just ask, because you know I don't mind repeating it again. It's not a big deal. Yep. So all I was saying when it came to this though is that you have your intersecting lines, and they create these opposite angles. 1 and 3 are opposite. 2 or 4 are opposite of each other, and that just means that they're going to be equal for us. Those are our vertical angles. Yeah. That's all I was saying. And that green statement down there is something that we've already talked about. You know, just restating that straight line is a straight angle, which is 180 degrees. Excuse me. Yep. All right. Questions on vertical angles? Can I scroll up?
Okay, can I ask a question? I hope it don't
Sure.
sound crazy.
Mm-mm.
Okay, see how you got those lines intersecting, they going across, right? And you have 1, 2, 3, 4.
Mhm.
These angles are not going to be the same amount of distance, right? One might say another number.
Well, 1 and 3 will be equal,
1 and 3 will be
and
equal.
2 and 4 will be equal.
Thank you.
Mhm. Now, you know, now it's not going to always be the same. It's not like 1 and
Right.
3 are always going to be 40 and, you know, something like that. But no,
Right.
it's just that if you know 1, then you know 3.
Okay.
And same
Thank you.
thing with, and then we'll see how we can figure out 2 and 4 as well. All you need to know is one of these angles, and you can figure out the other 3 angles. All right. So we're looking at this next example. I know I kind of jumbled it in here. This right here is the work, so that's not part of the problem. But this is what it would give us. It would give us find the measures of A, C, and D, and they give us that B is 115 degrees. So you wouldn't have this, or this. It would just give you, you know, your angles being intersecting, and then tell you one of your angles. So they tell us that B is 115 degrees.
A is 180 through 115.
Okay, don't look at that yet. That's the explanation. I'm just copy the
Oh.
problem. Yeah, I'm about to get into that in a second.
Okay. Just copy the problem. Okay.
Yeah. And so that's the explanation of your answers, but just give people a chance to copy the actual problem first. So now we have intersecting angles. Now going back to what we just finished talking about, if we have intersecting angles, then that means we have your vertical angle. I mean, not intersecting angles, intersecting lines, excuse me. We have intersecting lines. So because we have intersecting lines, then that means we have these vertical angles. All right. And that's where I was doing this right here, just to remind us that B and D are equal to each other.
Mm-hmm.
A and C are equal to each other.
Okay.
So whenever you have intersecting lines, this is what's created. It's a relationship that's created between the 4 angles.
Mm-hmm.
All right. So now we know what B is. B is 115.
Okay.
They told us that. That should be given in the problem. And then from there, we can find A, B, A, C, and D. So now, if you go off of the vertical angle relationship, B and D are equal. So that's what I got down here.
Wait,
D is,
B,
say again now?
okay, B and D, okay.
Yep, so D didn't call for any calculation. D is in dog. Is equal to 115, just like B is in boy, because it is a vertical angle with B. I tried to give a little explanation over here as to why we got those answers. So vertical angle with B is how you got D. All right, so is everybody okay with that one before we go to any of the other angles?
Yeah, Professor, a little explanation on why we did the 180 minus the 115.
I ain't got there yet. I ain't there yet. Y'all keep jumping on me. Y'all keep jumping. Y'all
Okay.
just let me guide you. Let me guide you. So we on D. We just talking about D right now.
Right. Got that.
All right. So everybody okay? That was based on the last, what we just finished talking about here.
Yeah.
All right. So, and I didn't mention this. I wrote B right here, but B was given, with the problem. All right. So now, remember that last statement in green, a straight line is 180 degrees. We talked about that. That's a straight angle. I can find angle A because it creates a straight line with B. A and B are going to be added. If you add those together, that gives you 180 degrees. Whenever you have a straight line, that's 180 degrees. All right. So that goes back to Ms. Glover's request for an explanation. That's why we did this right here. 180 minus B will give us A. So 180 minus 115 give us that 65 degrees. And once again, that's because A and B is a straight line. I know 115. I want to know what is A. So I subtract 115 from 180. And that gives me my answer.
So since the A is the straight line, is why it's 180. You keep saying
no. Not
A.
A. A is not a straight line. A and B. A and B, see the line? Angle B right here and angle A right here. Together they create a straight line. See, I'm talking about this right here.
I see the blue you're drawing there, but so that what makes this line, A and B makes this line.
Now, okay, let me put that back. All right, so let's say if I had this, get my angle back. Let's say if I had that right there. All right, this is angle A. Now, if I extend this out and make this B, notice that now I have a straight line right here.
Okay.
So A plus B is equal to 180 degrees because they give me a straight line.
I understand it, but I don't see the straight line between the A and the B on the other thing because like the B over there.
Like this. Look, tilt your head like this. Like, because that's what I'm talking about. You got to tilt your head a little bit.
Well, if that's the case, all of them is straight lines there, right?
Yeah.
Straight line.
You can make this relationship. I could have made this relationship with B and C if I wanted to and found C.
Because either way it go, okay.
Yeah, it's gonna give you the same answer. And that's why, and I hadn't gotten to that. Yeah, I was gonna get to that when we get to these other angles, right? Relationships. You're gonna have multiple ways of finding these angles. Yeah. So or if you wanted, you could have not use B and use D and C. Or you could have did D and A.
Okay.
You know what I mean? As long as you get that straight line made, whatever two angles help you create that straight line, you can subtract it from 180 to get the other angle.
Oh, wow. Okay.
Yep. So there's gonna be multiple ways that you can find the answer, but these answers are gonna still be the same. Like no matter what method you use, you're still gonna get these same numbers. Yeah. So yeah, and so now that you know A is 65, remember that's a vertical line, vertical angle with C. So it's gonna be equal to C, and that's why that's 65 as well.
Got that. I got that part. Sounds good. I think I got it now.
Okay, yeah, and it's going to take some getting used to. You're going to have to develop your eye to see the relationships between the angles and stuff. But yeah. But you're absolutely correct. You can find these answers multiple ways. All right, everybody done with that one before we get to this last relationship? All right, so notice the statements before we get into the diagram. Line 1, L1, line 2, L2 are parallel. They're parallel lines. So this only works if you have two parallel lines, and then you have a transversal. Transversal is just a line that runs through two parallel lines. So that is not that big a deal. Notice I didn't give an explanation on it because it's really not that big a deal. It's just you have one line running through two parallel lines. We're going to create a relationship, some relationships here. And let me erase these circles. So notice we have A, B, D, C, W, X, Z, Y. So we have the first relationship is alternate interior angles. So notice alternate, we're talking about opposite sides or alternate sides of your transversal, and interior, these four inside angles. So we're talking about those. So it's in the name, what relationship you're talking about, alternate interior angles. They're going to be equal. So that means D and X. Let me go with my purple back. Sorry, y'all, I mess with these letters. And then W and C, those are equal to each other. So those are alternate interior angles. They're on the interior. They're going to be equal to each other.
Do they have to be within the same little, could it be B and D? Could they be?
No, we just talking about alternate interior. Interior.
And they have to be inside them same two lines.
For this relationship, yes. Now we got two more relationships that we're going to talk about, but we're talking about this relationship right now. We're just talking about the alternate interior angles, those four angles.
So interior is because they calling it interior because they're both in between these two, exactly. Line 1 and line 2. Okay, that makes sense. Okay.
So the next one goes to those other angles you just mentioned, the exterior, alternate exterior angles. So we're talking about A and B, Z and Y. So alternate, I'm going to scroll up in a second, but just showing you guys. So that means B and Z, and then A and Y. They're going to be equal.
Give me 1 second.
Mm-hmm.
Okay.
All right, everybody good before we look at the next one?
Give me 1 second.
Just a second.
Mm-hmm.
Okay.
All right.
All right. You scroll up for the last one. You said we're good. So then the last relationship is your corresponding angles. And so they're going to be equal. I'll let you copy that down. Then we'll go back to the diagram. Oh, y'all good? Everybody?
Yes, sir.
Let's see, you told me to hold on, then didn't tell me you were ready. So we got corresponding angles. So just going back, so what this means is that you have your cluster. We have a cluster of angles here, and they're mirrored right here. So that means A and W, B and X, Z, D, Y, C. So you're just saying that that cluster is mirrored down there. So they correspond to each other. All right. So questions on anything before we look at an example that talks about these
Okay,
relationships?
you went up there and the ones in the, I'm sorry, you went up there, you
Mhm,
said the ones right here.
mhm.
That's
So that
the
means
cluster.
A and W are equal. B and X are equal. D and Z are equal. C and Y are equal. So that cluster of angles correspond to the cluster of angles down bottom.
Okay.
Mhm.
Okay, so this is here. Okay.
All right. We good? We good?
Mhm.
Everybody all right? Okay, so let's try it out. So in the diagram, it says L1 is parallel to L2. So that's what this means right here, that symbolism. L1 is parallel to L2. And they give you the measure of one of your angles. They tell you that F, I almost didn't get it out, F is equal to 58, equal to 58 degrees. And they ask us to find the missing angles. Don't copy this stuff down in green yet. That's the explanation. So just give you a chance to copy down the problem first. All right, we're good. We ready to start? So just like before, you have multiple ways of finding out the measure of these angles. I'm just giving you suggestions or different ways that I've done it. I did it when it comes to this problem. So the first one, F, F is given. F was 58 degrees. So then from there, the easiest one to find next is going to be H, because we're talking about these vertical angles, right? Whenever you have two lines that intersect, the opposite angles are equal to each other. So F and H are equal. And so notice that's what I wrote down here, that H is 58 degrees and it's a vertical angle with F. All right. Next, I found G. That's a straight, it creates my straight line. Remember we talked about that? And if H, I said H, well, H too, but if F and G creates that 180 degrees or that straight line, that's what we did right here. We subtract 58 from 180 and we got 122 for G. So SA is straight angle with F. Everybody okay with G and H? And then if you look at E is opposite of G. So E is a vertical angle with G. So that's why it's 122, just like G was. So before I go to A, B, C, D, is everybody okay with E, F, G, H? All right. So next we're looking at finding A, B, C, D. Now, if I wanted, I could just say that this corresponds to this and just find all of them straight just by using corresponding angles. I decided to switch it up a little bit just for board purposes. So CA is corresponding angle. So A corresponds with F. So that's why they're equal. A and F are 58 degrees. And then I said B corresponds with G. So that's why both of them are 120, 122, excuse me. And then I went ahead and did vertical angles. So A and C are vertical angles, so that's why they're equal. They're both 58. And then B and D are vertical angles. So that's why both of those are 122. Questions.
I don't have no questions, Professor, but I need a few minutes to make sure I write these notes so I can know what understand this good. So give me one second.
Mm-hmm. Okay, so I'm not doing triangles here.
Wait a minute, Professor. What that?
No, I was looking at something. You good?
No, I was just looking at C and D. What that VA stands for?
Vertical angles.
Okay, so they're
Yeah.
vertical and I had to write that out. So
Yeah, so remember that goes back to A and C being opposite of each other, opposite angles, and B and D in opposite angles.
okay, sir. Thank you so much.
All right. Don't do triangles. No, this section don't talk about triangles. Okay, so that's it for this section. Let me confirm with the assignment. Yep, just lines and angles. Yep. So we focus more on the calculator. I think I saw a few of them that asked, is this a line or this array? But y'all can just look at the examples on that one. We won't take up more time talking about lines and arrays. So I'm gonna pause right here. It's 125. Yeah, I don't want to start perimeter. I think I gave you guys enough to chew on today. Next class we'll do 7.2, which will be perimeter, area, and volume. And yeah, man. So don't forget, this is April 4th, and we only have like 3 weeks after this week left of class time. So yeah, make sure you guys are on top of that stuff and make sure you're getting your work done and all that good stuff like that. So before we close out today, questions, concerns, comments, anything, anybody? Anything, everybody good, everybody straight? So we have out of this section, yep. Okay, yeah, we're in a good place. All right, so try the stuff out, see if you get stuck. If you have any questions, always feel free to shoot me that that email or hit me next class or office hours or whatever you decide. Other than that, you guys have a good day, be safe, and next class we'll get into 7-2.
I got a personal question after we leave.
Yes, not a problem at all.
Mr. Tucker, do I